Hi friends, welcome to follow up. In this video, we are going to look at problem 1743, restore the array from adjacent pairs. Our purpose for this video is to explain the concept degree in graph theory. So here, this concept is associated with undirected graph. So our plan will be the following. First, we are going to digest the problem requirements, and then we explain the logic, and finally we share the code. So first, the problem digest. So here we are given an integer array called nums that consists of n unique elements, but we have forgotten it. So we do remember every pair of adjacent elements in nums. So our goal is to recover the array, right? So we are given a 2D integer array called adjacent pairs of size n-1, where each adjacent pair I equals ui vi indicates that the elements ui and vi are adjacent in nums. So actually, if you notice that there are n elements, so we can regard them as n nodes, and we have n-1 edges. So this is actually a tree, right? So it's guaranteed that every adjacent pair of elements will exist in the 2D array. So the pairs can appear in any order. So we want to return the original array nums. If there are multiple solutions, return any of them. So for this example, the first impression is that the return is not unique. For example, we can return 1, 2, 3, 4. Then we can also return 4, 3, 2, 1 at least, because the graph actually is an undirected graph, right? So if you look at example 2, so it provides another example. So here is one way, and then we can reverse it to get another way, right? So in example 3, so this is very simple, just have two elements, just return the two elements as a list. So here, actually, n is at least 2, right? Because we have at least one edge, right? So here, the number of nodes can be as large as 10 to the power 5. So there exists some nums that has adjacent pair as its pairs, right? So basically, it says that the solution must exist, right? There exists at least one solution. If it exists at least one, due to the assumption n is greater than or equal to 2, so it actually exists at least 2, right? Because you can consider the reverse. So that's the problem digest. So our goal is to explain the concept degree. So here we are talking about an undirected graph. So in an undirected graph, let's call it G, with vertices V and edges E. The degree of a node V is the number of directed edges connecting with V. So in this example, actually, the nodes of degree 1 can be used as the start of the array. Or if we want to use traversal algorithm, so this the node with degree 1 can be used as the source of the traversal in the coding. But due to the assumption of this problem, so actually we have two nodes of degree 1. So for example, in this one, 1 and 4 both have degree 1. So similarly, you can look at -2 and -3 in example 2. So with that said, we are going to look at the coding. So our plan is the following, right? So we build the tree or the graph. So here the graph actually is a tree. So we record the degrees of the nodes, and then we find one node with degree equals 1, then use it as source for depth first traversal will be sufficient for this problem because it's a tree, right? So once we find the one with degree 1, so we can regard that as the root of the tree, or as the source of the graph anyway, so the different wording. Then actually the implementation of the coding is rather straightforward. So for convenience, I changed the function, the argument name to A. So A is corresponding adjacent pairs, right? So first step we are going to do is build the graph, or more precisely in this problem, the tree. So this is simple. Actually, I'm going to use the default dictionary, right? So it's let's call it tree, right? So it's collections default dictionary. So I'm going to use a set as the neighbors. And also I want to have a degree. So the degree, I'm going to use collections default dictionary. So I will put a function or just a int, right? And then I'm going to traverse this A. So for u, v in A, right? So I'm going to do tree u. So v is in the neighbor, so I'm going to add v. So similarly, tree of v, I'm going to add u. So in both cases, so because there's an edge connecting u and v, so we're going to do degree of v is incremented by 1. So similarly, degree of u is incremented by 1, right? So then we have the tree, so we can print out this tree, tree or degree. Let's see, both. Print the degree. So let's do a test. So we're using this example, right? You can see 2 has a neighbor 1, 3, and 1 has just neighbor 2, and 3 has neighbor 2, 4, right? This 4 has neighbor 3. So you can see 1 has degree 1 here, and 2 has degree 2, 3 has degree 2, and 4 has degree 1, right? So once we're done here, so basically you can find one node with degree 1, right? So this is actually very simple, right? So we just need to use a traversal, right? So here what we want to do is, let's see, the source, I'm going to use this the source. So let's say -1, right? Because here, I guess, anyway, I don't care. So the nums of length is m. So let's change it to none, right? So for say node and degree in degree items, right? So once I find a degree that is 1, I just break, right? If degree equals 1, so I'm going to set source equals this degree, equals this node, and then just break, right? So this is once we find, we just stop. So you can print out the source if you like. So for this example, the source can be 1 or 4, right? Here we print out 1. So then let's do the traversal. I'm not going to write a hyperfunction because it's so simple, this problem. So do depth first based traversal. Here actually you can also do breadth first based, same. So here I'm going to use a visited as a set to monitor or to avoid repetition. The reason is that we are dealing with a undirected graph. So then the stack I'm going to initialize is this, right? The source, and then the basic loop. Well, s. So we're going to have the node. The node is going to be s pop left, just pop from the tail, and then let me also initialize a result, right? So this is the result array, right? So we have this if node not in visited. So I can do this. Visited, so because we are going to visit this node, let's first do this. So visited, add this node, right? Meanwhile, I'm going to append this node to the list to return, right? After this, we are going to check the neighbor of this node. This is very simple. For neighbor in tree node, then I just want to check if neighbor not in visited. So I'm going to append this neighbor to the stack neighbor, right? So afterwards, we just need to return the state of this result variable. So notice that here I do a check here, and also I do a check here. There are some redundancy, but if you write like this way, it will make your code very safe. So this is one solution format to this problem. So we can do a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I guess that's basically about it for this this video. So here we explained a concept called degree for undirected graph, right? And then we solve this problem by building the graph and tree and record the degrees of the nodes. And then we find one node with degree 1, and then we do a traversal to get the original array or list. So that's about it for this video. So actually we have a channel, and we have a large number of playlists within that channel. It contains different types of problems using different techniques. So you're welcome to follow up. If you want to support this channel, so you can just give a thumb up or share with your friends. So with that said, thank you.